Okay, in this section we're going to look at spirometry. It's only really 2 slides. I've got another slide in between these to kind of help go over it. This is going to tie in also with what we had in lab as far as the spirometry uh, experiment. So in order to look at the lungs, we want to, and their function, we want to look at how they function. And so we look at the different volumes and divide up the lungs in different ways. And this allows us to measure how efficient the lungs are and where areas they're going to be, where problems will arise. Anyway, the act of doing this is called spirometry. And on this chart, it tells various different divisions as it is. Now, I'm going to pull this up on another slide here. So it's up above and with another picture of the lungs down here on the bottom. Now, what I want to look at is the different volumes and kind of explain what we are trying to figure out. So the lungs have a total lung capacity. This one all the way over here on the right. Total lung capacity of roughly 6,000 milliliters, or it's said another way, 6 liters. So if we had 6 liters of fluid, or again 6 liters of air, we can fill this system from here all the way down to every pathway to those little alveoli. So if I had 6 liters, that's a bad thing. If I had 6 liters of air and I was able to dump it in, I could fill this container up all the way to the top. And so that's kind of what we're looking at with these volumes, is trying to figure out the different divisions. So, excuse me, if I had a tube that was 6 liters, we'll say, and this was the air, and the total capacity, all right, 6 liters. If I was divided up and have my lungs where we were looking at, there's going to be a little area where the air is going to be in it, and then I'm going to have one space that's got air and another space that has empty spots, so I can breathe into it. Now, if I was going to look at this and say, all right, as we're breathing, what's going to happen is this layer, which is the dividing line between where there's air and where there's not, is going to move up and down for each respiratory cycle. I'm going to put air into it, it's going to increase. I'm going to take air out and blow air out, exhale, and it's going to decrease. So I'm going to have a little bit of movement of this line. And so, I didn't mean to erase all of that, but I guess I did. That little bit of movement is what we refer to as the tidal volume. Wow, that stunk. And that is this volume. Tidal volume, which is going to be, on average, 500 milliliters, or half of a liter, is normal breathing. That is a normal respiratory cycle. 500 milliliters is going to come and go in this container. And so this little line here, again, dividing from where there is air and where there is no air. All right. This little line is going to raise and fall as I breathe by 500 milliliters. And that's called tidal volume. Now, there is going to be, again, this giant space at the top of that that's going to be a spot that if I need to breathe in more air, so I'm running or I'm getting ready to say something, and I know I'm going to talk for a while, take a deep breath in, and so I'm going to put some air, I'm going to fill in more than 500 milliliters, so I'm going to use this area, and it's called the inspiratory, which means breathing in, reserve, extra space, volume. So the expiratory or inspiratory reserve volume is simply empty space that I have access to if I need to take a deeper than normal breath. So it's a reserve tank, basically. So when I'm breathing normally, I'm really only using less than half of my lungs at any given point have air in them, and only about 500 milliliters or half a liter is going to be exchanged back and forth. So as I'm doing stuff, and I go to yawn, take a deep breath in, I'm going to overflow from the tidal volume, and I'm going to start tapping into this inspiratory reserve. And just like I've got an inspiratory reserve, an area where I can breathe in more than normal, I also have this area called an expiratory reserve, which is air that I can use to breathe out. So let's say I have to cough or sneeze. So I've got the normal amount of breath here at the tidal volume, going back to my little container, but I need to sneeze. So at the bottom of my normal breath, I have a set amount of air that is held in reserve just in case I need to breathe out more than normal. And that's called my expiratory reserve. Now, if I were to try to breathe all the air out, if I was going to take a deep breath in and try to breathe all the air out of my lungs, I will never get down to zero because I have these big tubes. These big tubes, the primary, secondary, and tertiary bronchi, they do not collapse. So I'm going to have this amount of air that's left over, and it is called the residual volume. Right? The residual volume is the air that is left over after I blow all the air out I can. So if I'm sitting here, and again, you can't see me, but if I was going to and blow the air out as much as I can, I will end up at a point where I cannot breathe out anymore. At that point, there's going to be a leftover amount of air, and it is called the residual volume. So like if you were washing your dishes and you think you did a good job cleaning it, and you look at it and there's some things left over, we would call that residue. Residue means something left over. Residual is that same word, the residual volume. So if we look at things and we divide it here, we've got four. We have tidal volume, which is normal breathing, and you do need to know that it is 500 milliliters. Then I have inspiratory reserve, a little pocket of free space so I can breathe in more than normal. And as you can see, it's not just a little pocket, it's about half of the lung. Then I have this other volume called expiratory reserve, which is air that I have in my lungs at the bottom of a normal breath that I can have access to breathe out. So coughing, sneezing, or talking for a long period of time. And then the last volume is this residual volume, which I said is simply the amount of air that's left over in all of these tubes. I don't know if anybody ever drank out of a juice box or a Capri Sun or one of those little things, and you got that little bit of fluid that you just can't get out of there no matter how much you suck on that straw. That's a residual volume. And so the lungs are going to have that too. Right? So those are the four volumes. All right? We've got normal breathing, and then we've got a reserve tank above and below. I've got a reserve tank for inspiration. I've got a reserve tank for expiration. And then finally, I have the residue, the amount of air that will never come out of my lungs no matter how much I try to force it, unless I get run over by a steamroller. So those are the volumes. There are four volumes. Again, you need to know that. Four volumes. Inspiratory, reserve volume, tidal volume, expiratory reserve volume, and residual volume. And then we go over on this side and we look at what are called capacities. Capacities are simply where I combine these. Now, there are four capacities that you need to know. One of them should be really straightforward. Total lung capacity. Now, total lung capacity, like I said, is 6,000 milliliters. You will see on this, there's about a little range here, about 200 milliliters that you'll never be able to tap into. Just like the residual volume down here, there's a little area here that our body will not let us use, because that if we get too full in our lungs, we run the risk of rupturing those simple squamous cells. We never can get into there. But I'm going to use, when I talk about this, I'm going to talk about total lung capacity as the 6,000 milliliters. Excuse me. So this one I think is relatively straightforward. Total lung capacity, you definitely need to know, is 6 liters or 6,000 milliliters. We get to another capacity that's called vital capacity. This one, hopefully you'll be able to understand when you figure out that this word vital means life. Vital means life. So if you are taking someone's vital signs, you are taking their signs of life. So if this is the vital capacity, and capacity is the combined volumes in one way, shape, or form, the combined volumes that lead to life are going to be the 2 reserve tanks and the tidal volume. The residual volume, I have no ability to use to get oxygen from them, but I can do that with the other 3. So the vital capacity is the entire lung capacity minus the residual volume. Now, hopefully that one makes sense as well. So you got vital capacity and total lung capacity. The last 2 are divided at the bottom of a normal breath. So a respiratory cycle goes from breathing in and breathing out. And that is 1 respiratory cycle, right? So a respiratory cycle starts and ends right at the bottom of a normal breath just before you breathe in. And so our body, or the way we're going to look at it is we're going to divide the lung volumes up at this line. So the inspiratory, so at the bottom of a normal breath, how much capacity, how much can I breathe in? And so it is going to be the tidal volume, which is this one, and then the inspiratory reserve volume, which is this one. So the inspiratory capacity is the combination of those 2. The last capacity is called the functional residual capacity, and it is the combination of the bottom 2. Functional residual, we just said residual means leftover, so at the bottom of a normal breath, right? So right here at the bottom of a normal breath, how much is left over? And so it's going to be the expiratory reserve plus the residual volume. Those 2 volumes are added together to make the functional residual capacity. So those are the different parts of this. The only 2 that I do want you to know numbers for are total lung capacity and tidal volume. I expect you to know the actual values for those. The other ones, I expect you to know what they are made up of. The capacities I'm going to have questions that are going to ask the vital capacity, what volumes is it made up of? So you need to know that. So this gives a rundown of them. Now, what we were looking at with spirometry and lab was simply on how it is used to measure. There's 2 lung functions. There's 2 types of lung issues. General classifications, we have obstructive and restrictive. Obstructive lung issues are areas that are going to be hard to breathe out because something's going to obstruct your breathing. It's going to, this is going to be where something's in the tubes, whether it's mucus or the tubes are constricted, and so it's obstructing the respiratory cycle. Restrictive is going to restrict the volume I can breathe in, because it's going to be like having a corset or some sort of girdle around your lungs, and it can't expand. So restrictive, we're going to have more problems breathing in. And so that's when we looked at these for lab. But anyway, these are the The volumes, now I will tell you, I always teach it as 6,000. This book has it at 5,800. I would know both of those. Honestly, since the book is going to be the one making the questions, I have to take it from the textbook. 5,800 is the total lung capacity. I do want you to know that it is 6,000, and there's 200 milliliters that is considered the safeguard that our body will not let us tap into. So that is going to be the spirometry portion of this.